So in this video, we're going to go through a slightly different example where we need to prove that for a is greater than 0 when a is not equal to 1, that 2 plus log base a of 4 over log base a of 2a is equal to 2. Now, before we get too worried about this, all that is saying is that this statement works when a is greater than 0, a is not equal to 1, because that is what we define logarithms to be. We don't work with a base that is equal to 0 or negative or equal to 1. Okay? So this is just saying the base has to be greater than 0 and it can't be equal to 1. But anything within that is fine. So let's look at our statement. Now what we need to do is we need to start from one side, and generally we start with the most complicated looking side, and we need to work our way to the right hand side, okay, through some algebraic steps. We do not multiply both sides by the log base a of 2a. You don't do that, okay, because that would be assuming that they are equal before you have shown it to be the case. So logically, we need to start with one side and show that it is equal to the right hand side. Okay? So we identify it as such in our working. So we can write the left hand side, which is 2 plus log base a of 4 over log base a of 2a is equal to, okay, and now I'm going to start my algebraic manipulation. Now the 2 I can write, because it would be useful if I write them all in terms of log base a, as log base a of a squared. Then we've got the log base a of 4, and we've got the log base a of 2a in the denominator. Now in the numerator we can combine those logarithms. So using the product rule, we can write that as log base a of a squared times 4, or 4a squared. Now, don't start thinking that we can write that as log base a of 4a squared over 2a. We can't do that, okay? So, we can't simplify these logarithms as they stand. So what we're going to do is we're going to recognise that 4a squared can be written as 2a squared. Because now I can use the power rule to bring that 2 down to the front. And now we've got log base a of 2a over log base a of 2a, and they cancel. And we just get left with 2, which was our right-hand side. And so we have completed our proof. And that has shown that starting with the left-hand side, we can arrive at the right-hand side, which must mean that the original statement was true.